Okay, in this lesson we're going to be learning how to use logarithms to solve equations. Now in order for us to be able to do that, we're going to have to know how to use what's called the change of base theorem, especially for those of you that are using a scientific calculator, not one of the TI Inspire calculators. Because if you have a TI Inspire calculator and you hit the log button, you get this on your screen. So you can just type in whatever the base is for the logarithm, and then type in the value and get your answer right away. But if you're using a scientific calculator, those are only set to be at base 10. Even if you have a graphing calculator like a TI-84, that too you cannot change the base on. So the TI Inspire right now is the only calculator that will do that. So what do you do if you have a scientific calculator and we need to be able to take a logarithm of a different base? Well, that's the change of base theorem. What that tells you, all you got to do is take the logarithm of your value of whatever a is and divide that by the log of whatever b is. And these would be common logarithms here. So take the log of a divided by the log of b. So let's look at this one. So make sure that you are using your calculator for this to check and make sure that you can get the right answer. But what you want to do here is you want to take the log of 18, divide that by the log of 5. When you do that on your calculator, you're going to get, let's see, log of 5. When you do that on your calculator, you get 1.796 as your answer. So you want to make sure that you got that, so you can make sure that you typed it in your calculator correctly. Make sure that you're not doing this. Don't do log of 18 divided by 5 and try to create a shortcut. There is no other way to do it. If you're using a scientific calculator, it has to be log of 18 divided by the log of 5. And you get, if you round to the nearest thousandth, which is 3 numbers after the decimal, you get 1.796. Now we're going to be using that to solve some different equations. Now we've done these same 3 steps previously, but usually it was with situations there where we would do it without a calculator, but these we're going to use a calculator. So the first step is to get the base by itself. By base, what I'm referring to is if you look at, you're solving an equation here, your variable that we're trying to solve for is an exponent. The base is the part of that the exponent is attached to. So the base in this case is the 7. I'm trying to get the 7 by itself. It is by itself. So I get to skip step 1 for this problem. My next step then is to change to the logarithm form. When I change to the logarithm form, remember this means that I have my base is 7. My value that I'm taking the logarithm of is that 28. It's equal to your exponent, which is x. And now if you have a TI Inspire, you can just plug this in on your calculator, take the log base 7 of 28, hit enter, you get your answer. But if you don't have a TI Inspire, you're going to have to break this up into the log of 28 divided by the log of 7. And when you do that on your calculator, you end up 1.712 as your answer. Now let's work on this next one together, at least start it out together. Here we have 2 times the 5 to the x power equals 32. Our first step is to look, here's our variable. That means the 5 is our base. I want to get that base by itself. Do not multiply the 2 times the 5 and say it's 10. The reason why we can't do that is order of operations tells us before we can do any multiplying, we need to take care of the exponent. Well, I can't do anything with the exponent for right now, so that's why we cannot multiply these together. My only option to get the x by itself is to divide both sides by 2. So now I have 5 to the x power equals 16. Now we can change to logarithm form. So in logarithm form, your base is going to be the 5. We're going to take the logarithm of 16. Your answer is going to be x. So you're going to plug this on your calculator now. And this time when you do that, you end up getting your answer for x is 1.723 if you round to the nearest thousandth. So there's your answer. So again, these steps that we're talking about today, these are important. These are what we're going to be using anytime we need to solve equations where we have a variable that's an exponent. And we've done these steps previously, so you want to make sure that you really do understand and know how to use each one of these 3 steps. because sometimes we'll be faced with story problems like this one. It says, at what rate of interest compounded continuously, so there's that phrase we've talked about, do you have to invest your money so it will double in 12 years? So we're using this formula, A equals P times E to the RT as your exponent, or PERT, because we're compounding continuously. Now we don't have a principal, but they do say that we want to double our amount in 12 years. Well, if we're going to double the amount we started with, that means our goal is to have 2P. In 12 years, your time is 12, so I'm going to write this as 12R. So now I want to solve this. So again, here's my exponent. Or there's my variable that's an exponent. So the base that it's attached to is the E. I want to get that by itself. So I'm going to divide both sides by P. That leaves me with 2 equals E to the 12R as my exponent. Don't do anything weird like dividing by E or taking each side of the 12R power. This is one of those where we just follow these three steps. We want to get the base by itself, which we did. Now I'm going to put it in logarithm form. Now when I put this in logarithm form, my base is E. But remember, log base E, remember what's that the same as? The natural log. So it'd be the log base E, or the natural log of 2 equals 12R. And then divide both sides by 12. And when you do that, we end up getting 0.058 as our answer. But remember, we're trying to figure out what rate you have to invest it at, so the rate is going to be at 5.8%. Look at this last one. This is real data. I got this off of the Census Bureau's website. And so in Minnesota, from the 2000 census, because they take a census every 10 years to track population growth. So from the year 2000 census to the 2010 census, the population of Minnesota grew by 7.8% to 5,304,000 people. If this growth rate continues, how many years would it take for the population to grow to 8 million? So here's how we're going to figure that out. We're going to use, remember we talked about this equation at the very beginning of the chapter, A times B to the x power. This is, anytime we deal with exponential growth or exponential decay, this is a formula we go to. So I know it's been a while. It's been since the beginning of the chapter that we talked about this one. You don't want to forget about this equation. This is an exponential equation. So here's what we got to do. We know our goal is to get to 8 million. Well, I'm going to write that as, I'm going to write that completely out. So 8 million equals your initial amount, which is 5,304,000, times your growth rate. 7.8%, that means it's increasing. It's growing by 7.8%. So remember, we add 100 to it, which gives you 107.8%, which as a decimal is 1.078. That's the value we're going to use for B. And then X represents your years. So remember, we want to get the base by itself, so I'm going to divide both sides by 5,304,000. And as a result, we get our answer, at least on this side, is 1.508 equals 1.078 to the x power. Now we're not going to divide both sides by 1.078. Don't do anything weird like that. Please remember these three steps. Our first step is to get the base by itself. Now the second step, we put it in logarithm form. When we put this in logarithm form, our base is 1.078. Our value that we're taking the logarithm of is 1.508. And that equals your exponent, which is just x. So if you don't have a scientific, or if you have a scientific calculator, you're going to have to break this up into log of 1.508 divided by the log of 1.078. And when you do that, you're going to get as your answer of about 5.5 years. And that would be your answer. So that's the last example that we're going to look at. So if you print out your assignment from Moodle. You'll see that you have some problems similar to this in that assignment. So after watching this video, hopefully you have a better understanding of how to solve some of these equations, but you want to make sure that you remember these 3 steps. If you do that, you'll be fine. So with that, good luck on your assignment.